In this video, we are going to take a look at some various problems using our trig, whether it be inverse or whether it be just our regular trig ratios. But the first vocab we need to talk about is whether or not our angle is elevated or an angle of depression. So angle of elevation is kind of like you're looking up. So this would be an angle of elevation. Angle of depression, kind of like our line of sight's looking downward below that horizontal line. So if we look at the first example here where we have angle 1, we are below the horizontal line, so we are an angle of depression, going kind of downward. And then angle 4 is this angle here. Here's the horizontal, and then here's the other part of the angle. We're above that horizontal, so we would be an angle of elevation. So kind of look for that horizontal and then whether or not you're above or below. So we are going to do some sketches here just to help us get basically our right triangle and then label our parts and then set it up and solve like we've kind of been doing. So we have for this one, we have a tree that casts a shadow. Shadows are on the ground. So our shadow down here is 9 meters long. We don't know the height of the tree, but that's what we're looking for, so I would label that X. And then our angle of elevation down here is 52 degrees. So now we know that we are needing the opposite. We have the adjacent, so we are going to be using the tangent of 52 equaling the O over the A. So remember, Ka, Toa. And that's a 9, not an A. I mean, it is the A, but. And then we're going to cross multiply. 1 times X is X. 9 times tangent, 52. We're going to be typing into our calculator. 9 times tangent 52 is 11.5. So our tree is 11.5 feet tall. So our next one, we have a person who is snorkeling. And they are just kind of above the water there, so. And then they see the turtle on the ocean floor. And there's my little turtle. So, pretend that is straight. So there's our kind of right triangle. So let's label our parts here. She is 14 feet above the ocean floor. So from her straight down, that's 14 feet. And then the angle of depression is going to be this angle here, but since it's the angle of depression, it's also the angle of elevation by alternate interior. So it's also this angle right there where the turtle is kind of meeting the ocean floor. And then we want to know how far away from the turtle she is. So this hypotenuse, it looks like, are going to be our X. It's what we're trying to find. So, from our angle, O and H, we know the O, we need the H, so we are going to be using sine. So sine 38 is equal to O over H, or 14 over X, and then we're going to cross multiply. So X times sine 38 is equal to 14, and divide by sine 38. So typing this 14 divided by sine 38 into our calculator, .7 feet away from the turtle. All right, so this one is already kind of labeled for you. I want you to go ahead and set it up and solve for the height of the roller coaster. So this is our x. Everything else is already labeled. So go ahead and circle your angle, label your two parts, and set it up and solve. So O and H is going to give us sine. Sine 55 is equal to the opposite, or x, over 98. Cross multiply. And taking 98 times sine 55 in your calculator, it would be 80.3 feet high. So we had 80.2769, and so this 7 is going to round that 2 up to the 3, 80.3. All right, so this one, we have our picture again already drawn for us. We have our angle here of 27. Now this 27 goes all the way up here, so we actually have to add together these two, and that is going to give us 30.5 feet for our opposite. And then our adjacent, we don't know, it's the x. So we are needing our adjacent, we know our opposite, which means we're going to be using tangent. So tangent 27 is equal to O, which is the 30.5, or 25 plus 5.5, over our x, or our adjacent that we don't know. And then we're going to cross multiply and divide by tangent 27. So x is going to equal, when we type 30.5 divided by tangent 27 in our calculator, approximately, so we get 59.8596. That is going to round it up. And this just said kind of round to, I think, the nearest foot. I thought it did, but yeah, so approximately 60 feet away. You could put 59.9, but approximately 60 feet away. Sometimes it tells you the nearest foot, or maybe 1/10 of a foot. All right, so try this last one. There's our angle. We're looking for this one. We have that one, so go ahead and set it up and then push play to check when you're ready. So O is what we have, A is what we want. Notice our angle of depression and angle of elevation the same there because they're alternate interior. So OA, TOA, is tangent. Tangent of our 52-degree angle is equal to the opposite over the adjacent, the O over the A. And we plug in O is 40, A is x. We cross multiply. 40 is equal to x times tangent 52, and then we have to get x alone by dividing by tangent 52. So this is what we plug into our calculator. We end up getting 31.2514, and so this 5 would round that up, or you could just say 31 since it's the nearest foot, so approximately 31 feet.